Hello everyone, welcome to Code Enzyme, and in this video I want to give you a challenge. I want you to pause this video here and try to solve this problem. And the problem goes like you have a series of numbers that contains only even digits. So the digits can only be 0, 2, 4, 6, 8 and 8. And few of the terms of this series are written here like 0, 2, 4, 6, 8, 20, 22, 22, 24, 26, 28, 40 and so on, like you can see. And you want to devise an efficient algorithm to find the nth term of this series. So I was solving an Atcoder Beginner contest and there I saw this problem. So I found that problem quite interesting and I just wanted to discuss the approach. So it's 2 a.m. in the morning and here I am making this video. And before starting this video, I would like you to hit that like and subscribe button because majority of my viewers have not subscribed to my channel, and it doesn't cost you anything, but it will help me a lot. So kindly do that. Thank you. And I'm assuming you have actually paused the video and given an honest try on your own. So let's start. So now let's try to build a solution. So we know the digits can only be 0, 2, 4, 6 and 8. Right. So my first thought was like, okay, we have this number. Now, can I, like, if my n was small, like in this problem, my n can go till 10 to the power 12. But let's say if my n was something small, my series is going like 0, 2, 4, 6, and 8, and so on, right? So my thought process was like I tried to make some observations here. So my first observation was like, okay, my first term was 0, second term was 2, third term was 4, fourth term was 6, and sixth term was 8, right? So one thing I was sure that okay, I can't make a pattern here. But what if I say my counting starts from 0? So my 0 term was 0, first term was 2, second term was 4, third term was 6, and my fourth term was 8. I mean, I made a typo here, sorry about that. But one thing I was sure that okay, my counting should start from 0, otherwise I will not be able to find an optimal answer. So that was my observation 1. If my counting is starting from 0, then I can say like, okay, if my n is less than equals to 4, my answer is simply 2n, right? If my n is less than equal to 4, my answer was simply 2n. Now I was okay, so let's try to make a few more observations. Now my series was going something like 0, 2, 4, 6, 8, and then I was getting a 20. So this was my first term, 0 term, 1, 2, 3, 4, and the fifth term was 20. So I started thinking like, okay, can I multiply 5 by 4? Like 5 into 4 was 20, right? That might be an answer, but the next term was 22, right? Now can I jump from 6 to 22? No, right? So I started thinking like, what can we do here? I mean, there are not many options here, but if you see, like, actually we are just trying to find this number. So is there a way to represent 4 as 8? I mean, I want to try representing like in the base 10 number system. In base 10 number system, we have 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9 digits, right? These are the digits that we have, and using these digits we represent every number. So why can we create a new base? So I started thinking like, can we create a new base number system which has only these digits 0, 2, 4, 6 and 8? Like, can we do that? Now I mean, I want to represent every number there is, like from 0 to infinity, using these 4 digits, like that. And actually that is the solution to this problem. So I mean, let's say I'm representing, let's say I don't have these numbers. Instead I have 0, 1, 2, 3, 4, and this is the base 5 number system. This is the base 5 number system, and you see the solution is actually pretty simple. if I have a number in base 5, so if I have something represented in, let's say, if I can represent a number as 12 in base 5, this is actually in equal to 24 in the new base system, right? So I can, what I observed was like, if I have a number in base 5, let's say, then I can simply multiply the digits by 2, and that will give me my answer in new base system. Like, let's see an example. I mean, it was purely by observation here. Let's say we have an example like, okay, 20. My fifth number was 20, right? So this is my fifth number. If I represent 5 in base 5, so it is equals to 10, right? Because it is equals to 5 into, I mean, sorry, it is equals to 0 into 5 to the power 0 plus 1 into 5 to the power 1, which is equals to 5, right? And then if I multiply this every digit by 2, then I will get a 20, right? Similarly, the sixth number, which is 22. So I want to represent 22 in the new base, and this is actually equals to 11 in base 5 when I divide this number by 2. Okay, so 11 base 5, and this is equals to 6 in base 10, right? It is a very intuitive observation, and if you were able to actually come up with it on your congratulations. Like, it is actually very tough to come up with it. So now, like, okay, we have this. So the algorithm is pretty simple from here. What we can do, if we have an n, we are given an n, we can go in reverse order. Like, we are given an n in base 10. Okay, first I have to do n minus minus, like n minus equals to 1. Like, because my counting is starting from 0 index, not 1 base, right? So first we have an n, then first we do n minus minus, then what we can do is simply convert it to a base 5 number. Whatever we get, then we multiply every digit by 2. So this is my answer. Okay, like 22 was a new base number that we were trying to form. I wanted to create a new base system consisting of 0, 2, 4, 6, 8, and from this 22, if I divided every digit by 2, then I got 11, and I consider this as a base 5 number system, and when I converted to a base 10 number, I got a 6. So that is the solution, and let's try to code this up very quickly and try to submit it. Okay, and also I forgot to discuss the time complexity. So the time complexity, now if we want to find the time complexity, we are given an n, so multiplication by 2 will cost us a big O of 1 time. Okay, then converting to a base 5, this will cost us a big O of log 5 n time, and then multiplying by 2, I think the complexity is log 5 n time. So for 10 to the power 12, it will be approximately 17 to 20 operations only. So it should pass in the given time constraints. Now let's try to code this up very quickly and submit the solution. Okay, so we have this problem here. Now let's create a new file. Yeah, and these are the test cases. So I will use my template, and let's remove the unnecessary comments. Okay, so first we have an integer n, and we want to find the nth term, right? Okay, now in the algorithm here, first what we did was we subtracted 1 because our indexing is 0 based, so n minus minus, and then I want to convert this number to a base 5 number, right? So let's say int answer, and we want to find the we will also want to multiply this by a power of 10. So like, if we wanted to convert the integer to into a base 5 number, I'm storing my final answer in this variable. So I can say while n answer is equals to answer times not times, answer plus equals to what? Now I have to take mod, right? N mod 5, and n is equals to n by 5. Now only one thing is remaining. I have to keep multiplying with the power of 10. So let's say int pw equals to 10. Not 10, I will start with 1. So times pw. Now I will multiply this pw by 10. Why? Why I'm doing this step here for those who don't understand. Like let's say we are doing it for n equals to something nice. Let's say we are doing it for n equals to 133. Yeah. So we have 133 and we want to convert this. First I'm doing n minus minus, right? So we have 132 actually. And I want to convert this to a base 5 number. Now let's first take the mod of 132 and 5. So 132 mod 5, so 132 mod 5 is equals to 2, right? And what we are left with, so we have a 2. And what are we left with when I divide 132 by 5? We are left with 5 2s are 10. So 3 2, 5 6 are 30, 26, right? Yeah. And now when I take modulus again of this, so we get a modulus as 1. Right. Now we have this modulus, and now what do I do here? Like I want to add 1. So I want to make this equals to 1 2. So I can't directly add this. First I have to multiply this 1 by a 10 and then add the new digit here, right? So that is why I'm multiplying my answer by 10 or the power of 10 at whichever digit index I want to place it, and that way I am doing it. Now since n is 10 to the power 12, this will not overflow because I have converted my integer to long integer. So it should pass in the given time constraints. Now in the end, I just have to multiply my answer by 2. So I can say cout answer times 2 and endl, right? Endl is not actually required here, but let's see. Now let's try to run this code and see if it is working. Okay, it passed, and now let's try to submit this code and check the status. So I hope you were able to solve this problem by the end of this video, and if you did, kindly like this video and subscribe to my channel. And for more such video, you can comment down if you have any other interesting problems that you want me to make a video on, and I will see you guys next time. Thank you.